Hey, hi guys, good morning.
Hi, Shrikant. I have one question here.
Yeah, go ahead.
So, regarding that global descent, am I correct? Sorry,
Gradient descent.
gradient
Gradient
descent. I'm
descent.
sorry.
Yes,
Yeah.
yes, yes.
So there we had spoken about global minima and local minima. So
Uh-huh.
initially you spoke that the cost function we start with the left hand side, but when you
No,
talked about
it can start from either side.
actually, it can start
Basically,
from any side. And
any
because that is
side.
what I
So,
was saying. If it is a long curve up and down, so where do we
uh,
start? Do we start from left or right?
no, so I'll explain. So just a second. So it is randomly. It will get initiate randomly. So there's no fixed um, point from where it will start. So randomly it will start
So,
and
yeah,
slowly,
yeah.
slowly it will come down, it will descend, and finally it get converge where the slope is equal to zero.
Okay. So
Okay.
for that, yeah, convex curve you showed when
Yes.
it was a
Yes.
quadratic sort of thing. You said it will only go to
Yes.
the point where it finds the slope to be zero. Now, but if
Mm-hmm.
it is a up and down like a long curve,
Right.
so in that case, will it traverse the whole curve to find the global minimum?
Uh, yeah. So let me share my screen. So in that case, basically, it will get into a local minima trap. So I mentioned that point, right?
Yeah,
So
yeah, yeah.
let me cover that point, how basically that can be dealt. Okay, so your question is if it's up and down, what's up, then how it would handle, right? See, now if the curve is like this, then there is no issue, right? It's a cost
Yeah,
function.
yeah.
It's
Correct. If anyway it
basically
starts, yeah, it will
it
find the
starts from, as I mentioned, it randomly assigns the parameters, okay, be it like coefficients or when we discuss about neural networks, then it is denoted as weights, right? W. So the whole purpose of this gradient descent is to find out this optimal weights at which the cost function is the minimum. So randomly it assigns the weight, so it can randomly assign this weight or this weight, whatever. Okay, and so if it starts from here, then it will gradually traverse downwards and then it will converge here. If it starts from here, then it will gradually move downwards and it will stop here. So it's a simple.
correct.
Now, as you mentioned, if the curve is something like this, right, where you have multiple minimum points, right? So these are known
Correct.
as local minima and this is known as global minima. So basically, the objective of this algorithm would be to reach to this point. But what will happen is, let's suppose the weight randomly got assigned here. It will go down, go down, go down, and it will stop here because here the slope is zero. It will not descend because it will not understand where to move, right? Because the slope is zero. Here the slope is towards downwards. So that's the reason the algorithm would move downwards, and that's how the weights will get updated. Okay, the weights, if it's a single weight, then the weight will decrease, decrease, decrease till it reaches to this particular point where the cost function is the minimum. Now, this is known as local minima trap because there is a scope of further improvement, right? If the model or if that algorithm reaches to this point, then that would be a better um point because at this point the cost function is much lower than at this point, right? So there comes the batch gradient descent.
Okay.
Batch gradient descent, or there is another thing is stochastic gradient descent. Okay. So what is this batch gradient descent? Just think about this. Okay. So let's suppose you with your friend, you went for an excursion. Okay. And you are just having, you're just playing a game saying that, okay, all of us will go blindfolded and let's find out the deepest point. Okay. So let's suppose you all start from here. Let's suppose from here, this point. Okay, and you're all blindfolded. So now you will take a small, small step and you will reach to this point. And after that, if you take another step, you will feel that you are going upwards and you will stop there. Right. It's
Mhm.
all blind game. So now you will say that, oh my God, we reached here, but there is a deepest point that side. So what you will do is, you will divide into batches. You will say that two people, okay, start from there, two people start from there, two people start from somewhere else, right? So let's suppose one batch starts from here, another batch starts from here, another batch starts from here. Now this batch would lead to the deepest point, while other batches will lead to this local minimum. Okay, and finally all these will be compared, like at which point the cost function is the minimum, and that will become the final optimal point at which
Okay.
the cost function is less. Stochastic is more of the word stochastic in statistics means random. So what will happen is this whole process will randomly repeat multiple times. So first of all, as it is random, so it may start from here again the randomly the weights will be initialized, and it may start from here, it may start from here. So there might be a chance that randomly if we initiate multiple times, okay, there is a possibility that it may reach to a global minimum. Got it? So these are the ways, and internally, in all these algorithms, basically either of these two are used. It's not a simple gradient descent. It's more of a batch and stochastic, where the random initialization happens multiple times. So that the algorithm should reach to the global minimum. But if the problem is too complex, then we have to set certain number of steps. Okay, we need to just mention that, okay, take these many steps. It may reach here in those steps, it may not reach here, because if it's a complex problem, it may take a lot of time for this algorithm to reach to this particular form. And if we want the model to train faster and quickly, then we may set certain number of steps, and it may reach here. So definitely there could be a further scope of improvement, but even this level could be fine, right? So if we are okay with that, so we can set certain number of steps. Here, what are these steps? And I will cover this. I thought of covering this in more detail in neural networks, but let me give you a high level. What are these steps? So the steps taken. This is nothing known as learning rate. So this is set to a very small value as 0.01 or 0.02. Okay, based on that, it will take the steps. If you want to make it faster, then you can increase this learning rate. So if you increase the learning rate, it will take a bigger steps. But again, there is a problem. So for example, the analogy which I've given you, if you're taking a baby step, to find out the deepest point, so there's 100% surety that you will reach to this particular point. But let's suppose if you're taking a big steps, okay, a big leap, you are jumping, right? So you may jump here and then you may jump here. So what will happen? You may miss out this particular point. Then again, if you jump here, so you're taking a bigger steps. So in that case, it may miss this minimum point. So there's a reason we cannot go with a higher learning rate. The same time, the challenge with smaller learning rate is it will take a lot of steps, to reach to the this minimum point. So you have to choose learning rate in such a way that it should not miss the minimum point, and the same time it should be faster, to reach to that minimum point to converge. So typically we take 0.01 or 0.02, but this could be one of the hyperparameter in the this is one of the hyperparameter in the neural networks, which we have to change and see which particular learning rate is giving you the minimum cost function. Okay, so it's a very broader topic, but to just to to answer your question, if there are multiple minimum points up and downs, then we either go with a batch gradient descent or stochastic gradient descent. In batch gradient descent, the different batches will initiate from different points, and in that way, it will identify the minimum point. Okay, and the stochastic is like random. So randomly, the algorithm will initiate from various different points, and so that it will converge to a global minimum. Okay.
Okay. And just one more question here.
Yeah. Yeah.
So in the linear regression, you spoke about two algorithms to get the regression.
Yeah.
One was sklearn, another was the stats model. So
Yes.
sklearn was maths based, and the stats model was statistics based.
Statistical. Yes.
So which one would you recommend from your
sklearn,
experience?
sklearn.
Okay, but that is from the compute or memory side.
From the compute side, that is good. But see, if you want to prepare a report, okay, a statistical report, why you went with a regression model, and if you have to provide some statistical summary of the model, then you go with the stats model. But even for the deployment purpose, see, that is just for validation whether your model is good or not, or for comparison, or for to provide the some kind of summary of the model to uh, to help your stakeholders to understand why you're going with this model, okay, to prove that this model is good. So for that, that summary is good. But when it comes to implementation, or if you have to move that model to production, then sklearn is the best. Okay, it will not break on the whole model, okay, and it will be faster. And in this machine learning implementation, it's not something once you train the model and your job is done, right? You have to continuously monitor whether your model is getting degraded, or whether the accuracy of the model is going down. That continuous monitoring needs to be done. And if you feel that your model accuracy is going down, then there is a need of a retraining, and that has to be quick. For example, your model is integrated to some application which is being consumed by 100 of users. You cannot stop that application and train that model, take 1 hour or 2 hours, and then again deploy, right? So there would be a completely breakdown of that application. So for that, we basically we go with sklearn because it is very quick. So if you are taking a larger data set, it will quickly train the model, and you can able to deploy it back to your application within no time. So for practical implementations and for monitoring purpose and all, sklearn is the best. Stats model is more for statisticians. So if you have to show somebody, or if you are doing some kind of R&D, if you want to find out whether your variables are significant or not, all that kind of analysis, if you have to do, then you can go with stats.
Okay, thanks. Yeah, that is good enough. Yeah.
All right. Any other questions, guys? All right. Okay, so now here today we will talk about um, a new algorithm known as K nearest neighbors. In short, we call it as KNN. Okay. Uh, Before this, I wanted to cover the logistic regression, but that I will cover tomorrow. Um, this particular uh, algorithm, though it is very simple algorithm to understand, but it is yet very effective. Okay. Now, as I mentioned in machine learning, there are two different kinds of problems. One is the regression problem. Regression problem is about where your output variable is a numerical variable, basically a continuous variable. Then we call that particular problem as a regression problem. So here you can have in the input variables, you can have continuous as well as categorical, but your output variable has to be continuous. So that problem called as regression or numerical prediction problem. Now the second problem is known as classification problem, where your output variable is a categorical variable. Okay, so by the word you can understand. Now this model, what it will do is it will classify the data points with the categories. Okay, whatever category fits well for that particular data point, it will classify that particular with that particular category. So for example, any customer. Okay. So now in your database, let's suppose you have classified all your customers into four categories, like high potential customer or potential customer or average customer or whatever. Okay. So based on the kind of revenue you are getting from those customers and based on the frequency at which they are buying, so you have categorized all your customers. And why do we categorize the customers? Because it will help you to target your customers better, okay, and even to service them better. So we call that privileged customer, right? What do you mean by privileged customer? So because you are getting higher revenue from those customers, so you have to treat those customers in a different way. There would be certain customers who are very uh, who some once in a while, they come and they buy a product or they buy services. They are not regular. Okay, so for them, you will not spend time and efforts, to target them. So like that, there are multiple use cases where the data points, the observations have been categorized into multiple categories. And now if any new customer comes in, instead of manually going and understanding their behavior, the customer behavior, the patterns, and then classifying it, I can use a predictive model, which will directly classify those data points or observations. So if you have that kind of requirement, in those requirement, your output variable has to be categorical. So in that, for those problems are called as classification problem. So we have discussed about linear regression. That is, you have seen that there the output variable was continuous in simple linear regression, also in the multiple linear regression also. For the classification, there is another statistical model known as logistic regression, which we will discuss later. Uh, but it would be good if we have one single algorithm which can serve both the, which can meet both the purpose. Okay, so one such algorithm is KNN. Though it is very simple, you will when you once you understand the way it works, you'll find, oh my God, it's so simple, right? But we use it more often, because easy to implement, even the accuracy is good. And if you understand the logic behind this particular algorithm, you will say, yes, it makes sense, right? So knowingly or unknowingly in our real life also, sometimes we use this particular approach to make certain decisions. And now from now onwards, whatever algorithm I'm going to discuss, these are these are the outcome of our real life. So what these guys have done is, the researchers who have come up with this algorithm, they have studied the human brain. They have studied the psychology. They have studied the way we humans we behave, we understand things, and we make conclusion based on that. So all that they have studied, and based on that, they have kind of came up with all these algorithms. Okay, and they have even understood the nature. So there are certain algorithms, search algorithms, which are like advanced algorithms, which are based on our nature. So, for example, there is one algorithm known as ant colony optimization. So they have even studied how these ants, okay, they behave. You have seen the behavior of the ants, right? If one ant moves, then the another ant, follows that particular ant, and there would be a big chain of ants, right, which moves, which follows one another, right? So in on that particular uh, mechanism, they have come up with one ant colony optimization algorithm. There is a swarm optimization. So how the swarm flies, okay, and then accordingly other swarms follows. Based on that, there is a bee optimization based on the behavior of the bees. So all these living creatures how they behave, based on that these algorithms have been framed and structured. Okay, it's very interesting. And there is a genetic algorithm also. So how, if you have studied about biology, how our gene mutates, and and there is a new birth of new, what do you say, living being. So the same way the search algorithm has been, genetic algorithm has been built. So the point why I'm telling all these things is, now from now onwards, whatever algorithm I'll cover, try to relate it with your real life. In that way, it would be very easy for you to understand. Okay, and even when you are solving any problem, think about that, which particular approach would fit well on, to solve that particular problem, and, select the algorithm accordingly. And that way, it would be very easy for you to solve any kind of machine learning problem. Okay. So now coming back to this k nearest neighbors. So let's understand, what do you mean by neighbors here? Okay. So neighbors, it's an English word. It's like the closest uh, observation in this case. So basically, this overall algorithm, what it does is it finds the closest observation. Okay. So it's something like, in our real life, if we say, right, okay, if that person is close to somebody, so if any person is close to somebody and we know that person, okay, with whom that person is close, if we know that that person is bad, then we automatically will tag that, okay, this person will be also bad. If that person is good, then we will tag this guy also. So it's all about the company, with whom you are closer, with whom you are talking, and we make a perception, right? Okay, if this person is with these guys, okay, I know that this person would be also like this, and we classify, right? So the same way here, this is the as simple as that. Okay, and even for the regression case, what it does is, this algorithm, it will find out the nearest observations, and it will find out the value of all the nearest observation, and it will take the average, and then that particular average value will be the predicted value for that particular observation. So it's all about finding out the nearest neighbors, a similar observation, uh, for which you want to make the predictions. It will find out the similar observations compared to that particular observation. And based on those neighbors, it will make the predictions. Either it could be regression problem or it could be a classification problem. So for example, in this case, now I have, and the good part with this algorithm is, you can have as many number of input features. So you name it, everything is there in this particular algorithm. It is scalable, it can work on larger data set, it can solve regression problem, it can solve classification problem. But there are certain challenges. So I talked about all advantages of this algorithm, but there are certain disadvantages also, which I will cover in the end. And you will also agree with those points. So let's suppose now I have these many independent variable, okay, and one dependent variable. So now here it is a classification problem. I have a customer category. So I have all these categories, 1, 4, 3, okay. So I have 4 categories. The first category is the basic service. So these are the customers who have opted for basic service, or, these are the people, whom less, we are getting less revenue, and they don't require much attention. Okay, so these are those people. Then these are the second category of people where they have opted for e-service. So basically, this data is related to telecom. Okay, so they have opted for certain e-services. There are third category who have opted for some premium services, plus services, and these are the category of customers who have opted for overall all the services, okay, which this telecom provider is providing. So think about, like, these are the postpaid guys and these are the prepaid guys, and these are the people, on the prepaid, if they have opted for some other services like data and all, something like that. And these are the some of the people, who have opted for even further more services. Okay, so now we have this categorization done for these customers. Now there is a new customer which is coming up and you want to categorize. Okay, so I have put it very simple, but if you have to categorize, it's not just, what kind of services they have used, but it will also cover their demographic details. It will also cover their behavior, their payment history, everything. Okay, in the real life, I'm saying, the real problem, we consider all that data together. Okay, and then we categorize the customers. So basically, for customer categorization, we generally use these three parameters, R, F, M. R is means recency, F means frequency, M means monetary. And these three parameters help us to understand the behavior of the customer. Recency means how recent the customer is, how active the customer is, how based on his last purchase, I can score a customer based on the recency. If there is one customer who has bought a product just yesterday or day before yesterday, so that person is more active, is active in the system compared to a customer who has bought a product, let's suppose 2 months back or 3 months back. So there his score would be less when compared to this guy. Then the frequency, how often that particular customer is buying my product. So that's something I can understand from the historical data. So if there is a person like who is buying a product every month or every quarter, compared to a person who is buying a product after on an average after 6 months or 7 months, so there the frequency score would be less. Monetary, of course, it's a revenue from which customer I am getting more revenue. So these are the most important parameters, and on top of this, a lot of other parameters can be also added. But typically, these are the three most important parameters which can help you to understand the behavior of the customer. So we call it as RFM analysis. Okay, so coming back to this, let's suppose I have this data where I have added some demographic details and I have some other data. Now I want to there is some categorization done on my historical data, and based on that, I want to train my model, which can able to predict the category for the new customers. Now, how it works is, firstly, all this data, it will map it on the n-dimensional space. So there are many dimensions, right? But for this particular plot, they have just considered age and income. So on age and income, these are all my customers, and these are their locations. Basically, we call as coordinates. So these are the coordinates of these customers. So this particular customer is located here in this particular graph, in the 2D graph. Just imagine if you have 15 variables, then there would be a 15-dimensional space. Okay, we call it as an n-dimensional space. In that, every observation will be located at particular point. Now, just to make you understand, let's suppose this point is here, and this particular customer for which I have to make the prediction, the coordinates of this customer is age 50 and income 166. So here it goes, right? So this person lies here. Now, if you just consider the first KNN, K means the number, okay? K means the number and nearest neighbor. Okay, so if I'm going with one nearest neighbor, you can assign K equal to 1. So if you're going with one nearest neighbor, then this is the closest. This observation is the closest. Now, if this observation is the closest, I'll find out from which category this particular observation belongs. For example, it belongs from this category number 4, okay, which is total service. So I will label this customer also with the same category. So think is like this, right? If you have similar kind of an attributes, if the with and if the two people have similar kind of attributes, generally we believe that they both will have similar taste or same kind of mentality, same kind of behavior. We assume that, okay, if their attributes matches. So same way here, if all the attributes which we are taking in the input variables are like closest, they are very close to each other, then we consider that that person will belong to the same category as this particular person belong. Okay, so as this person is marked into total service, then this person will be also marked to the same category because the income is the same, age is the same, all rest of the other variables are also the same. So definitely, okay, if that's the case, then even the manually also, if you go and do it, you will mark the same category because there's a logic you will use, to categorize these observations. So that's the whole logic behind this. Now, how this mathematically, how it finds out whether, which observations are similar. So there comes the distance measure. Okay. So this is at k equal to 5. Typical. So just tell me, if we go with k equal to 1, what kind of problem we may face? Or do you think if it is okay to compare with only one nearest neighbor? Yes or no? Is it fine if we compare any new observation with only one nearest neighbor to make the prediction?
No.
No. Why no? Just think about from the real life, okay? What kind of problems or what kind of mistakes we can do, if we are going with only one similar, one nearest neighbor. See, let's suppose, yeah, go ahead. Somebody wants to say something? Okay. See, generally there could be some exceptions, right? In the world, there could be certain exceptions. What if, this particular point with whom you are comparing, that is an exception? You will tend to make mistake, right? So, in the real life, there could be people like, who looks, who looks very casual, but they are kind of serious. Okay, Uh, those are like exceptional. So in my college, there was a person, who always seen outside. Okay, we never seen that person studying. Okay, he always outside having fun. Okay, he always chill with his friends. So we used to have a wrong perception that this guy, he's never serious, but he always come, second or first in his class. So that was an exception. So if anybody is with him making a conclusion that okay, this guy also casual, it's kind of a mistake, right? Because that person is studying, okay, and he is scoring good marks, but though, his attributes doesn't look very serious. So there could be certain exception. So if we are going and comparing with only one nearest neighbor, probably, our prediction may go wrong, okay, sometimes. So, and we call these exception as an outliers. Okay, so we talked about outliers, right? In the data, that's the biggest problem what we may face is the outliers. And you have seen in the linear regression models also, if they are an outliers, there is a problem, right? Your model may get biased towards those outliers, and it may lead to uh, a bad model, right? Here also, if there is an outlier in the data, and if we are going with only one nearest neighbor, then because of that outlier, uh, we may do certain misclassifications. Okay, so for that reason, it's always better, to go with a higher k value. Now tell me why not 2? Okay, why 5? Why I'm showing 5? Why not 2? What is the problem with going with 2 nearest neighbors? Think about it, okay? So if one is not correct, then we can go with 2. But what is the problem with 2? So the problem with 2 is, for example, if one nearest neighbor falls in one category, another nearest neighbor falls in another category. Like for example, this first one belongs to category 1 and second one belongs to category 2. How you will decide which category, to label this particular observation, right? If one person is going on, moving along, with one serious guy and one casual guy, then how you will label this guy? Okay, as a serious or as a casual guy, right? So it would be a tie, and again, the predictions cannot be made, right? So it's always better go with an odd number, because if you find the majority of the observations falling in one category, that majority category you can assign it to your new observation. But if you say why not three, and so basically in any typical classification problem, there would be three or four classes, right? If I go with three, then again I may end up with this kind of a situation where the third category, a third nearest neighbor may fall in some other category. I'll go with a higher number, okay, like five or seven or nine. Usually I'll go with odd numbers so that there couldn't be any kind of a tie in between the categories. Okay, so for example, I'm going with the five nearest neighbors. So now this is the observation which I need to classify. I found the five nearest neighbors. So here, irrespective of how close these are, but I'll go with a majority category. So out of this five, three belongs to this particular category number three, and two belongs to category number four. Okay. So I will label this particular category as three. Now, if you see, when I went with k equal to 1, I had to categorize this particular, classify this particular observation as category 4. But when I'm going with k equal to 5, now I have to go and categorize this particular observation with category 3. So that's the difference you will find, okay, if you are changing the k value. So now for this particular algorithm, k is very critical. This k value, deciding what would be the k value, that will uh, that will decide the accuracy of the model. And it is not a fixed rule. There is no thumb rule. It is again iterative. You go with 5 and check the accuracy. If it is not good, change it to 7, change it to 9, 11, and see, which particular k value is giving you a better results. So these parameters like k here is called as hyperparameter. Okay. Every algorithm will have some hyperparameters. So for this k and n, this k is a hyperparameter, and if you change this hyperparameter to improve the accuracy, that process is known as hyperparameter tuning. So basically, the way you tune the radio. So the radio you tune, right? So there is a knob which you will rotate, and at at point at which the signals catches properly, you stop. The same way here, hyperparameters, it could be one or it could be multiple. So you keep on changing their values, and you will stop at a value at which your accuracy of the model is better. Okay, so here for this algorithm, k is one such hyperparameter. So test it on 5, test it on 7, test it on 9, 11. So the best practice is take the odd number, but there is again no fixed rule. So take the odd values, train the model at various k values, and see at which k value you are getting a better results. Okay. So now see, with k equal to 5, now this has labeled this particular observation as category 3, which is plus services. Now, for the classification, again, there would be a actual value, okay, in your data, and there would be a predicted value. In the training data set also, there would be actuals, and in the test data set also, there would be an actuals. So you train here in this case, there's not much training. I'll tell you why. Because here there is no model as such. It will not remember the location of everything. It's something like, every time whenever you have to make the predictions, you have to pass some data to this model from which, it will compare. Okay. So for making this prediction, you need all these data points, right? Otherwise, how it will locate to which particular observation this observation is closer. Okay. So it is something like you are going for an exam and you are carrying a cheat sheet with you, right? So this particular algorithm, there's a reason it is called as lazy learning algorithm. So it is not learning anything. It is taking some kind of data along with it, through which it is making the predictions. So to make any predictions, it requires all these observations. So this observation is nothing but, this is nothing but your training data set. You pass the training data set when you are making any predictions, and for every observations, it will look out from in the training data set which of the observations are closer to this particular new observation, and that's how it will make the classification. So once you are making the classification, so on the test data set, you will have the actual values and you will have the predicted values. So for the classification, it is very simple to evaluate. The error would be all the right classifications divided by total classifications. So if you have made 100 total classifications, out of that 80 are the right classifications. Sorry, this is your accuracy, not error. So the accuracy would be right classifications divided by total classifications. So that would be your accuracy. It's simple. Okay. And error would be 1 minus accuracy. If out of 100, 80 are the right classification, 80% is your accuracy. And 20%, 100 minus 80, that is your error. 20% is your error. Okay. Now things comes like how it finds out these similar observations. Okay. So we have the coordinates. But with the coordinates, how it finds that these are the only 5 observations which are closest. Okay, so that is done based on the similarity. Okay, so it will find out how similar other observations are with this observation. So basically, it will find out the similarity with the entire data, and there would be a similarity score assigned to it, and then it will sort it with the descending order. Wherever the similarity score is high, it will pick those as the nearest neighbor. Now, how it finds out that similarity? Basically, I hope you might have came across with this particular distance measure. So here we go with a Euclidean distance. You might have heard about it somewhere. So Euclidean distance, it's a very simple formula. I hope there would be, yeah. So here it is. Okay, so let's suppose I have these two customers. Okay, so customer one, these are the coordinates 34, 190, let's suppose. This is another customer 30 and 200. Now I want to find out the distance between these 2 points. So it would be a straight line. I will find out the distance of this between this point and this point. So that distance can be measured through Euclidean distance. So this is the formula. So the difference between the x coordinates, 34 minus 30, I'll take the square, plus distance between the y coordinates. Okay, 190 minus 200, I'll take the square. And then I'll sum it up and then I'll take the square root. So this measure is known as Euclidean distance. So it is denoted as x1 minus x2 square, y1 minus y2 square. So it could be, if you are dealing with n dimension, then you will have n dimensions. Okay. So for example, 3 dimension, then you will have z1 minus z2 whole square. So like that, you can add as many number of dimensions as possible. Okay. So with this method, I will find out the distance. So the inverse of the distance is known as similarity. If the distance is more, then similarity is less, right? Because they are very far from each other, so they are not similar. They are like dissimilar. If the distance is less, then the similarity would be high, okay? Because they are very close to each other. So this distance measure helps us to find out the similar observations. So what it does is, this algorithm, it will take the training data set. So one data set, it will use it as a cheat sheet. Okay, so that is the training data set. And in the training data set, you have to be cautious of the fact that whether that particular data set is capturing all the different categories or not. Okay, for example, in overall uh, organization, okay, the customers are getting mapped into 5 categories. Those 5 categories should be there in your training data set. It's not like you randomly pick some data in which only 3 categories are there. Then those 2 categories will be missed out because this KNN needs that entire data, which it will go and map. Okay, so once you give the training data set and also ask the KNN algorithm to make the predictions, so what it will do is it will take that new observation on which the prediction has to be made, and it will go and compare with the entire data set. So all these colorful points, what you are seeing, this is the entire training data set, right? So from this training data set, it will try to find out the nearest neighbors. So based on that distance measure, right? And whatever k value you select, based on that k value, it will select that many number of nearest neighbors, and based on that, it will make the classification. Now, if you see here, as I said, k is considered as a hyperparameter. So now k will be compared with accuracy. At k equal to 1, what is accuracy? At k equal to 2, what is accuracy? So here the accuracy is high at k equal to 4, so I'll go with 4. So every use case is not just like go with a blind rule as k equal to 4 for every use case. For every use case, probably you may have to go with different k values, because for that particular data set, in some of the data set, even k equal to 2 would work well. So because in that data set, probably the categories are very distinct. Okay. And so even the lower value may give you a better accuracy. But if you are working on a very complex kind of data set where certain categories are even overlapping, or probably they are very close to each other, in that case, taking the higher k value would be better. Hope you guys are following, right? So now when it comes to a regression, it can also be used for regression. So let's suppose I want to find out the house prices. So this is the data for housing prices. So I need to find out, let's suppose I have a house here. I need to find out at which price should I sell, okay, this particular house. So now what I will do is I will find out some nearest houses, okay, which are very much similar to my house, okay, based on the size and all those things, and the amenities and all those things. So let's suppose I'm going with k equal to 3. These are the three nearest or very similar kind of houses. So even the location matters. So I cannot compare my house with some other house which is located 30 kilometers away, right? So these are the three closest similar houses, you know, compared to my house. Now, I'll find out the price of these houses. Okay, what is the price? And let's suppose these have been recently bought by somebody. So I'll find out the price of this. Let's suppose it is 1 million. This is 1.5 million. This is 2 million, let's suppose. So what I will do is I'll take the average of all these prices, 2 plus 1 plus 1.5 divided by 3. So that would be the predicted price for my house. Okay, so now in this case, my output variable is a continuous variable. Okay, and I'm using this KNN to predict that continuous variable, which is the price, right? So the same concept, finding out the nearest neighbor, and based on that, I'm taking the mean. So for the regression, I'll go with mean, and for classification, I'll go with mode. Mode is what? A category which is having a higher frequency. So out of 5, if 3 is from one category, then the third category is my mode. So I'll use mode for classification and I will use mean for regression. Okay. So this is what is KNN. Is it simple? Yes. Guys, you are there with me? Harishri, Saurabh.
Yes.
Okay. So any questions so far? All right. Okay, so let's
What is the
quickly.
use case here? I mean, how will we use it? I mean,
Sorry, what is the
use case? I mean, how will we use it? I mean, like in what real-time scenarios will you use this algorithm?
Yes, let's cover that now. So let me pull up the data. Now, this data, what you're seeing, this is a again telecom customer data. Okay, the one which we were seeing on the slide, right? So now I have some demographic details of these customers. Okay. See, now the customer segmentation can be done for for multiple things. One is like for customer acquisition. What is customer acquisition? You go to the field and try to acquire some data related to, you know, basically they are not your customer, but they can be your potential customer. So you go and collect the data of people around in the market, right? You and then you decide, then you will decide whom you should target. So you might be getting a lot of calls from the banks, right? Would you like to take the loan, or you want to buy some policies and all those things? Though you are not the customer of that particular bank, still they will call you. So that is known as customer acquisition. So they might have some understanding about your income. They might have some understanding about, how much, what is your credit score or something. Okay. So they will feel that, okay, now this is the guy, whom they can target and who can be your potential buyer. Okay. You can be their potential buyer. So they just don't call randomly. They will have some categorization done. Okay. And based on that, they will make a call. And when they are making a call, even what product and what services they need to sell, they will also categorize accordingly. So these customers, let them sell, let us sell these services. For other set of customers, let us sell these kind of services. So this is that kind of a data set where there is our attributes of the customers, potential customers, and then they have done some categorization what to sell to these customers. Okay. So this is all the historical data. They have seen that, okay, these people with these kind of attributes, they have bought this particular service, basic service. For the people with these kind of attributes, they have kind of bought total services, right? And that's how, they have categorized all these customers in their historical data. Now, based on this, you can train the model. Now, when let's suppose you have seen people, right, outside, they will do some kind of a survey, right? They will ask your uh, interest specifications, okay, some kind of basic questions they will ask. So they will take out everything, and based on that data, they will try to categorize you. Okay, so what kind of services, and this is a big business nowadays. People are selling the data, you know, at a premium rate. Okay, so Airtel sells the data to some other customers. There are many other data providers. If you go and ask them, okay, I want some data related to this age group, what they do, what they buy, how they, what kind of hobbies they have. I need to have some kind of information. So they are companies who have that kind of a data. If you are launching some kind of a product, you want to understand what is the customer behavior or what are their customer preferences. There are certain data providers who will provide you the data. Okay, so once you have that kind of a data, now you can think about it like whom to target, whom not to target, right? So this is one such data set. And if you have a model around it, once you get the data from the field, you can directly use this model and you can categorize rather than going through every data point manually and then classifying it, whether we should target this person or not. Instead of doing it manually, I will run this predictive model on top of it. It will, at one go, it will classify all the observations, and whichever to whichever uh, people, it will mark it as a potential category, then I will go and target only those customers. So this is my data set, and here all these values are categorical. Sorry, they are continuous as well as categorical. So for example, marital. So it has two categories, 0 and 1. Now there is a region. So there are three categories, 1 and 3. And there are some continuous variables like tenure, which can take any numerical value. We have age, which is again numeric. So here employment number of years of experience, I guess. So it is also numeric. Retire, it is binary 0 and 1. Gender also binary. Residence, okay, there are so many categories here. So here the data is mixed. I have continuous variable, I have categorical variable, and based on these all input variables, I have to classify whether that customer belongs to uh, category 1, 2, 3, or 4. Okay, now this is the use case. Did you guys get it? The use case. So it is a classification problem where I need to classify the customers. For that, I am training the model now. Okay, so let me pull up the Jupyter notebook. You can think about other use cases also like defect detection, right? So, or machine failures. So there the input variables could be voltage, temperature, vibration, a lot of other parameters of that particular machine. And your output variable could be just binary, right? Whether the machine will fail or not fail, 0 or 1. So based on those attributes, you have to classify whether machine will fail or machine will not fail. Similarly, for the defect detection also. So if any product is having these kind of specifications, so can be considered as a defected or it is not non-defected product. Okay, that's also something you can classify quickly with the help of this predictive model. Okay, so let me go ahead and okay, so I hope you can see my Jupyter node. Yeah. So this is my data set. I've given you some brief description about this data set. So here I'm loading it. So this is my data, which we have just seen in Excel. Then first is like you do some kind of EDA. Okay, and just go and draw some charts and to understand because see with this EDA also you will get a lot of insights. Okay. Um, for example, you need to understand what is the level of income, okay, of the people and what is the distribution of the income of the people. So you're seeing that mostly the people are of low income and there are only very few people who are at the high income, so it is completely skewed. Okay, so there is a long tail on the right hand side. Okay, so there are people with higher income as 2000, close to 2000, and most of the people are here who are like close to almost like zero. Okay, so probably they are retired, they don't have any income, or probably the people are from uh, lesser age groups, so which is who are having a very low income. So, so you can quickly test the data, whether your data is good enough, to move ahead and build any predictive model on top of it, or to make any analysis. You can make a quick analysis by plotting these charts and understanding the data. Okay, so here what I'm doing is I'm converting all these variables into an array. So you have seen yesterday that even for linear regression, before we train the model, we are converting the data frame into array. And I told you the reason. This data frame takes larger space, larger memory when compared to the arrays. I'll give you the example here. So basically, it's about bytes, okay, bits and bytes. So when you go with a data frame and you uh, or you label a particular column as float, then the float values will take uh, certain amount of space, okay, certain bytes. So we call a 64-bit space, okay, they will take. While integer will take 32-bit. Okay, so if you convert that into an array, you see that after dot there is no values it is taking, right? If there is certain values, then only it will take it. But for rest of the other values where there is no decimal values, okay, it will not consider that much of space. So with that, it will consume less memory and the computation would be faster, right? So in sklearn, all the algorithms uh, it requires arrays, to train the model. Okay, so the first step is always the first step is to convert that data frame into an array. Okay, all the variables. So here, either you can use the previous method, what we have discussed in linear regression, as array, or else you can just directly say dot values. If you say dot values, it will automatically convert that into an array. Okay. This is a quick way of converting any data frame to an array. So now this is an array. Now it's showing it as an array. And now this is the label. This is my output column, customer cat. Okay, and I am naming it as y. These are all x. Okay, all the input variables. And this is my output variables. And now both input and output variable have converted into an array. Now what I'm doing is I'm normalizing the data. Now this is very, very important step for KNN. Now, if I move back to this particular presentation again, um, let me take this slide. Okay, so not this. Okay. Now let's suppose this income column. Just assume, okay, it is this big number, okay. Now, when you are calculating the distance, don't you think that this particular column will dominate? This particular variable somehow, it will be ignored. Okay, if there are certain variables at a very large scale, there could be certain variables even, a very small. For example, take something like which is in this kind of scale. So in front of a scale like this, a variable which is having values at this scale will be completely ignored, right? So to avoid that, what we will do is we'll bring all the variables, all the columns into the same scale. Now that is known as scaling. Now how we do that? One is like we calculate the Z score. Okay, so we call it as Z transformation. Okay, so what we will do is we convert all the values into a Z score. And when we convert all the values into a Z score, it will be of same scale. Okay, where the mean will be equal to 0 and the range would be some minus number to some plus number. Okay, so if this is the value, let's suppose the mean of this particular variable is, let's suppose 0.06. So the first value would be 0.01 minus 0.06 divided by standard deviation. Let's suppose standard deviation is 0.02. Okay, so there you will get some number. So if you have income which is having a higher number, where the mean, let's suppose, is around 120,000. So this number would be, number would be 190,000 minus 120,000 divided by, let's suppose, the standard deviation is 10,000. Okay. Now this will also, this value would be very much similar to this particular value. So in that way, all the variables will be standardized and we call it as standardization, where we will apply some scaling technique. And based on that scaling, all the variables will fall into a similar scale. So that you will see in this particular data now. So here, if you see the data here, it's like in units, here it is into tens. There are some hundreds. Okay, could be some thousands. Okay, so the variables are at different scale. Now, to standardize this data, we also call as normalizing the data. The normalizing the data, we go and use this one technique known as standard scaler. So this standard scaler is nothing but it will convert the values into Z-score. And if you see now, this is my first column, this is my second column, this is my third, fourth column. All the values looks like to be on the same scale now. Now this is known as pre-processing, okay, and this is very important because if you don't transform your data, if you don't scale your data, you will end up into a problem where the variables which is on a higher scale will dominate, and your distance and your similarity measure will be more influenced by those variables, okay, which is on higher scale. So this is the must step, and it is mandatory when you are going with a KNN model. Okay, so what we are doing is here in sklearn we have a module known as pre-processing. In sklearn, import pre-processing. And inside that pre-processing, we have this particular function known as standard scaler. There are many other scaling techniques, but usually we go with standard scaler where we are converting the values into a Z-score. Now we will say dot fit. What fit will do is in this particular input data, it will find out the mean and the standard deviation of every variable when you say fit. Because for calculating the Z-score, you require a mean value and you require a standard deviation. So when you say fit, it will calculate those parameters. And when you say transform, then what it will do is it will go and calculate the Z-score for all the values, okay, by using those parameters. Okay, and then I'm converting that into a float value. So see, this something I'm doing it step, at once, okay, for the entire data. So this is my new data now, transform data. And once the data has been transformed, now I'm going and splitting the data into training and test. Okay. So this is how, yeah. So in the last use case, we have used some traditional way of splitting the data, but you can do it quickly by using a model selection module in sklearn. And in that, you can use this particular function known as train test split. So in this train test split, you just mention what size you want to consider for your test data set. Here I'm going with 20%. So remaining 80% will be considered as a training data set. A random state is, so here this is all random sampling, what I'm trying to do here. So if you set a particular number, okay, to this random state, every time whenever you run, you will get a similar, you will get the same test data and the same training data. If you don't put it, every time it will randomly generate some new training data set and new test data. So to get the exactly the same test data and the training data, it's recommended that you should use certain number. So if you are sharing this particular code with somebody and you want that person to run and to get the same results, so you have to set this random state so that he will also get the same training data and the same test data. Okay. So now this is my size of the training data set and the test data set. Now here I'm going and training the model. Here there's no training as such. Here I just need to feed that training data set to this particular model, and that training data set it will consider as a reference data set to find out the nearest neighbors, and based on that it will make the classification. So from sklearn, again there is a different module altogether for algorithms which works on this based on this concept of neighbors, right? So they have created a module known as neighbors. In that we have one algorithm known as k neighbors classifier, and there would be another function known as k neighbors regressor which will be used for regression problem. Okay, so here I'm going with classifier. Here I've decided k equal to 4. So k neighbors classifier, I'm passing this k value here, and I'm saying dot fit and passing this training data. It will do nothing. Okay, there wouldn't be any kind of a training here. It will just take this data and save it. That's all, and it will consider this k as 4. Now I'll go and make the predictions. For making the prediction, I'll use this model and I'll say dot predict, and I'll pass the input variables of the state test data set. Okay. That's all, and it has made the prediction. So the first observation in the test data set, it has labeled as 3, second, it has labeled as 1, and so on and so forth. Okay. Now here I'm going and finding out the accuracy. So on the training data set, I got the accuracy of 55%. On the test, I got only 28%, which is pretty bad, right? Sorry. So accuracy is very low, and there is a huge difference between training accuracy and the test accuracy. So in that case, this model is of no use. Now, what I will do is I'll go and iterate for different k value because I have to improve the accuracy. So I'm going and iterating for various k values. So this is a loop which I'm running. Okay. Um, and for every k value, and I'm calculating the accuracy. So this is how I'm finding out the accuracy. So after finding out the accuracy, I'm just saving it. So these are my all accuracy score for different k values. So I'll show you this particular chart now. So at various k value, this is the accuracy. So it looks like, at k equal to 3, basically it is highest. It is around 0.33, but still it's of no use because any accuracy, if it is higher than 0.7 or 0.8, then only that model is considered as a good model. So here the best accuracy I'm getting at k equal to 3 as 0.31. Okay. So overall, if you see for this particular data set, this KNN model is not giving you a better results because probably there are not good patterns in the data through which we can classify these customers properly. It's not always uh, that, whatever data set you will get, you can able to train the model with higher accuracy. Okay, sometimes whatever you do, whatever algorithm you consider, not you may not get a better accuracy. So in that way, you have to uh, we have to consider that that particular data is not good, for predictions. Probably the variables are not enough, or probably the variables are not significant, or probably that problem cannot be solved, okay, with that particular data. So you have to sometimes, and most of the times, we encounter this kind of a problem. And if we encounter this kind of a problem, and what we do is we try to enrich the data. We ask for more data. We go for more variables. We add more data, to the existing data. And after a lot of iterations, finally we may get a decent model, right? So it's not compulsory that whatever data you will get, you will end up getting a good model. You can train a good model on top of it. You should try. You should try all. So here I've tried everything. Okay. So there's only one hyperparameter which I can try to fine tune the model, and I've used different k values. Still, I couldn't able to get a better accuracy. So, so what is the next step now? Probably I may go and try some other algorithm. That's one way. Other way is like probably I'll ask for more data, ask for more variables, and try to enrich the data so that I can improve my accuracy. So there are only two ways only: either improve the data or else change the algorithm. Okay, so just go through this code, okay, and let me know if you have any questions. Tomorrow, I will talk about evaluation of these models, classification models. So there are certain evaluation metrics associated to these classification models. We'll talk about confusion matrix. We'll talk about precision, recall, um, ROC curve, AUC score. So all that we will discuss tomorrow. And then tomorrow we'll also touch this logistic regression topic. Okay, so I'll stop here. Let me know if you have any questions, guys.
One question. So this code that you have written here for this k nearest neighbors. So is that like a standard procedure like you have to follow in this format and just like replace variables based on your requirements?
See, every person has a different way of writing the code. So this is something my way of writing the code. So where what I've done is I've labeled it, I've inserted the comments, and then step by step. And you can add these all lines into one section, and you can run it at one go, right? So people can do that also. But overall, the task needs to be performed should be included in your code. First thing is like you have to obviously you have to import the data, right? After importing the data, you have to do some basic analysis of the data. You have to do the EDA. So here I've just created only one single chart, right? So now you can create charts for every variable. You can create different other kinds of charts, or you can do some other different kind of analysis on the data based on your requirement, based on your interest. You can do all that kind of analysis. And then after that, the pre-processing is important. Okay. So then you have to do some kind of pre-processing. Here we have done the scaling. You need to understand for which algorithm, what kind of pre-processing is required. For KNN now scaling is mandatory. So you have to definitely perform that scaling. After the scaling, when the pre-processing is done, now you have to train the model. So you go and train the model. And after training the model, you have to evaluate the model. So this is the step-by-step process for solving any machine learning problem. Now it's up to you how you have to write the code. There is no any fixed rule like you have to first import the line in one cell and then import the data in one cell, and then you have to perform other activities at a separate cell. So there is no hard and fast rule that you have to follow the same way of coding, but the steps has to be you know these are fixed. Like you have to import, you have to analyze, then you have to pre-process it, then you have to train the model, and then you have to evaluate the model. This is the procedure which you have to follow. Coding is up to you. However you want to code, you can code. Okay. Did I answer your question?
Yes. Thanks.
Thank you. Any other questions, guys? Okay. So I'll share this code and data. Okay. Just go and practice and let me know if you have any questions. All right, guys. Then thank you. Have a nice day. Bye bye.